All right, I hope it doesn't happen again. What just happened? I'm not sure why. I'm not sure why for some reason YouTube just decided to like kick me off and go to a different stream. That was really strange. But I hope we're able to get some people back and start right from where we left off. I'm gonna just continue where I left off. Hopefully Marvin comes back and we can keep talking about JavaScript for a little bit. But we in part one, this is part two of the stream that I had just put up. Part one, we finished minimum cost of buying candies with a discount. Now we're going to do find the difference. So hopefully we're back up and running now. Nothing happens because I'm trying to keep continuity here. Don't know why YouTube would just kick me off like that. It's not cool. All right, let's see this new one here. You're given two strings S and T. String T is generated by random shuffling string S and then add one more letter at a random position. Return the letter that was added to T. Okay, so find the difference. We just want to see which letter. Okay, so find the difference from what? S and T or random shuffling string S and then add one more letter. Okay, so I guess we can have, yeah, okay, let's see. Let's try and figure this out. Now I'm gonna be really like paranoid about what YouTube's gonna be doing in the background, just in case it decides to kick me off again. So we're going to have this new character that's generated, that's T, and string T is generated by random shuffling string S and then add one more letter at a random position. So is it worth it to say, like, I feel like right off the bat I can say if s.length, right? If s.length is equal to 0, can I just return T? Else, what if we just got, and are these, I'm guessing this consists of lowercase English letters, return the letter that was added to T. I think what I can do here is we can say like const alphabet is new array size 26. We'll fill this up with 0. For const C of S, we can say alphabet of C equals alphabet of C plus 1 or 1. And I mean, I feel like, oh wait, we definitely need to get the index though, right? Const index equals C dot car code at 0 minus 97. Inside of here, we'll do the index. Can I just do for const C of T, we'll get the index. So now I want to find if the letter I'm on was not in S. I mean, is it safe to say if alphabet of index is equal to 0, return C? Is that okay? I don't want to make this maybe easier than it sounds, but EY, EIEIO. Okay, so output undefined. Let's see. So what happened here? We did, okay, so it's not necessarily, okay, I see. Of course, I should have thought that you can have more than one character. So it's not so much that. I guess the frequency needs to be the same. So if it's 0, if alphabet of index equals 0, or let's see, can I do both of these in one? If it's equal to 0, that means we found it at E, but not the other one. We can return C. Or if the alphabet at this current index, so if this is greater, let's think about this because there's 2 here. So it would actually be nice, let's think about this. Do I need to get the frequency of both? I guess I can get the frequency of both, and then, so let's do this. Let's say, yeah, let's do this. Let's say get frequency. Let's do this. Inside of here, I'm going to create const alphabet. And then we'll do, and we'll get the frequency of, let's say, string. inside of here, for const c of string, index c.carcode, alphabet of index equals alphabet of index plus 1 or 1. And here we'll go ahead and return alphabet. So let me remove this, right? So I can say get s frequency is equal to get frequency of s, const get t frequency equals get frequency of t. And now what we can do now is we can just go through t. I think now we can say like for const c, or maybe what are we gonna get here? Let's do it one of these for loops. For let I less than get t frequency dot length, or maybe instead of get t frequency we should just say s frequency and t frequency. T frequency dot length I plus plus. So now we just need to find ones that are not the same. Anytime it's not the same, then we know that should be the character, right? So if t frequency of I is not equal to s frequency of I, okay, now this gives us the alphabet. These are the frequencies of each. Now we have to return the letter. So I think what we can do here is we can return string dot from, is it string dot from car code? From car code, okay. So let's do from car code of I plus 97. Let's see what this yields. EY and EY, and let's get this input now. Okay, let's do this. EYA and A. Okay, so well, let's submit this and then we'll go over it. Okay, nice, very cool. So what we did here is this first case, I'm not even sure if we really need this. Would it? I think we can probably even get away from doing that. Let me run the code again. EYA, EYA. Okay, let's run that. Okay, so we have this function right here that essentially creates a new alphabet array and fills it up with the frequency of each one of the different strings. We get the frequency for S and the frequency from T. And then all we do is we have this I variable that goes through the frequency. So I is going to be 0 through 25, each representing a lowercase character. So whenever we know that the frequencies are not the same, that's the difference. Now, I, for example, if I is 0, that's A, but I cannot return like 0 because first of all, that's not a character. And I also can't return string dot from car code of 0 because that's not A. So I'm adding the 97 back to sort of undo this piece right here. So if we think about time complexity here, each one of these operations, let's see, is going through str. So if these are both of, these will both be different lengths, right? And I think, yeah, it's going to be really, yeah, I guess m and n, I suppose. Or you can do m plus, or yeah, m plus 1. Which I'm sure there's like a nice way to simplify that, but math is not like my strong suit, but really it's m plus n is the time complexity. This over here, t frequency, is going to be constant because we always know that t frequency is going to be of size 26. So here I would say the time complexity is m plus n, where m is the length of s and n is the length of t. And the space complexity here, let's see, will be constant because it doesn't matter the size of S or T. We're always creating an array of size 26. So I like this question a lot. Very good question. I'm very happy with the questions we've done so far. So I also like this one. I will include it on my website. Oh, wait, I can't like it and dislike it immediately. All right, cool. Let's keep it going here. So implement queue. Oh, this one's solid right here. Implement a queue using a stack. So let's think about this one. Let me see. Okay. So I'd like to do this one with an image here. So I think it's going to make it It's going to make a lot more sense if we do that. All right, cool. So implement a queue using stacks. Implement a first in, first out queue using only 2 stacks. So let's think about how our queue works. Right? So we have, I mean, it's just like a ride. Like think about like a ride in Disney World or something, right? So we have this one here. I'll give this one a color. Let's imagine, and let's just say we have a couple of these. So we have different people in our line. We have one that comes in, right? Another one comes inside the queue. Another one comes inside the queue. Another one comes inside the queue, right? And then this one comes off. This one comes off. So it's first in, first out, right? That's how a queue works. So if we have 2 stacks, we can represent stacks. And for this one, I don't want it to be, I want that one to be transparent. Let's imagine here we had 2 different stacks, right? So if I'm adding something to the stack every single time, like let's say I push 1 and then I'm pushing another one, I feel like every time I push, because what happens as soon as I want, like let's say I did a push and a push and now I do a pop. If I do a pop off stack 1, I'm going to get 2, but 2 should not be first, 1 should be first. So I almost feel like we should pop into stack 1 and then we're going to try and pop into stack 1, but since stack 1 is already full, like it has at least one thing, we should instead, let's see, maybe we can just push into here, and if the length is greater than 1, we should be popping and then pushing into the other one. That way anytime we pop, we just pop off the non-empty one and pick out the most recent thing. So let's kind of go over this and see how it works. Maybe I should have made this, if I put a 1 there, is that like easy to see? Maybe not. Probably shouldn't make it like, what's like a nice clear color? Yeah, I don't think that's going to be very legible. Transparent. Yeah, I want more of these. Let me remove these guys and let me duplicate these now. So let's do 1, 2, 3, 4. So let's imagine we're gonna push into stack 1, right? Now imagine again starting in the beginning. Yeah, what's up, Marvin? Thank you, thank you. Yeah, that was so weird. I don't know what happened. I really don't know what happened. And let me just make sure we back. Let me see. Yes, we are. Let me see. I don't know why okay, there. I just wanted to make sure the chat box was coming up. Okay, so imagine we're pushing 1 and then we push 2, okay? Now if I did a pop from here, if I did a pop from the queue, I would expect 1 to come out first, but in this case it would be 2. So what I could do is I can push, like if the stack is empty, or we can just always push, right? If it's greater than 1, it's not, it's 1. So then we push. If it's greater than 1, it is. So now we have to pop everything off of this stack and move it to the other stack. And I think that's mainly the main operation. And then anytime we pop, we just pop off the non-empty one. So this is like we pop off 1, then we pop off 2. Now, if I pop off 2 and then I do 3, I do the same thing. So I pop 3, pop 2, and now I'm left like this. No, you're good, Marvin. Like, seriously. Actually, I'm glad you said it, because you're sort of like, it's one thing for me to view the analytics, but it's also another thing to have viewers actually tell me like if we're doing the stream all right. All right, so let's go over this, right? I want to do 2 different stacks. So let's say this stack 1 is an empty array, and then this stack 2 is another empty array. What happens when we push? I think we need to push, let me see. We want to push to the non-empty one, right? Or I mean, can I always just make it, the one, const stack to push equals this dot stack 1 dot length. If that one's empty, let me see. Well, it's not the empty one, right? We want to push into the non-empty one. So if stack 1 dot length is equal to 0, maybe we should set this to stack 2 else this dot stack 1. So we go into the non-empty one. Then we say stack to push dot push x. And then now the tricky thing is like, which one do we pop to? I mean, I guess we can say const stack to pop to, or stack to pop. So if this dot stack 1 dot length is 0, this will be this dot stack 1, else it'll be this dot stack 2. So we can say while stack to push dot length is greater than 1, or we only want to do it if it's greater than 0, right? While stack to push is greater than or equal to 1, only if it's greater to 1. I think here it should be that we push it to 1. Okay, that's fine. We come the next time, we push it. Now it's greater than 1. So let's see, if we push and it's greater than or equal to 1, I don't want to pop unless I have to. So I guess here we can say if stack to push dot length is greater than 1, we can say while stack to push dot length is greater than 0, we can say stack to pop dot push stack to push dot pop. I know it kind of seems like wild what we're doing here, but hopefully this will all make sense in a moment. So if the thing we just pushed to has a length greater than 1, right? So let's remember how this looks. If it's greater than 1, so we start in the beginning, we push. So let's say const stack to push. If this dot stack length is 0, which is the empty one, right? We want to push to, I guess in the beginning it doesn't really matter, but let's see. Stack to push, let's say it's going to be stack 2 first, because we're going to do push here. Stack to pop, if stack.1 length is 0, okay, so this is the one we want to pop to. While this has a length greater than 1, we do something. So right now we don't do anything. Let's say we get to the next one. Stack to push. If this dot stack 1 dot length is 0, stack 2 becomes stack to push. So we push 2 into stack to push. Now we say stack to pop. If this dot stack dot 1 length is 0, which is this one, yes. Stack to pop is equal to stack 1. We can say, well, if stack.push.length is greater than 1, which it is, while stack to push.length is greater than 0, we're going to push onto stack to pop, which remember is this one, pop whatever is on stack to push. So we'll pop it. It still has a length greater than 0. We'll pop it. And now its length is 0. So now we're here. Okay. So the next time we come, let's see, stack to push. If stack 1 dot length is 0, which is not, we do stack 2. Okay, so what happens here? If I push stack 3, can we do this? If stack 1 dot length is 0, I think anytime that I'm about to push, I think what I need to do, let me see, maybe I should, like, it's almost like, okay, I'm about to pop here. But let's see. I think I did this backwards. It should actually be 1, 2. I go to 2. So I pop 2 here. I pop 1 here. I'm about to put 3, but maybe before I put 3, yeah, I need to push 3 into the empty one. But now do we pop 1 and 2? No, I don't want to pop 1 and 2, right? Because 1 still needs to be the one on top. So yeah, I thought we were close, but I think there's one little logic error that I have here. If I want 1 to be first, if I push 2, I should push 2 and then I should pop these. Okay, that means that now I can pop from the non-empty one. If I push a new one, if I push 3 in here, for example, what is it that I want to do here? I definitely don't want to, I can't lose track of this one. So do we need to take like 1, 2, push 3, and then 3, 2, 1? 3, 2, 1. Is that always we have to do? So every time we push, we pop, we put in another one, we push it. So let me write that down. Let me write that down because I think maybe that's a different algorithm that I hadn't thought about before. So before we push, we move, pop from one stack to the other. Right? So let's say before we push the 4, we pop from one stack to another. Okay. Push new element to that stack. We'll push this one to the new one. And then pop from new to old. So we go from here and we always do this. So I guess one of them will always be empty. Right? So we're always going to pop from the non-empty one. Let's start this again. So before we push, we pop from one stack to the other, which here nothing's really going to matter. This, okay. Okay. If to the other one. So we need to also know which one. Let's do this. Before we push, pop from one stack to the other. So stack to pop. If this dot stack dot one length, but then this will always be equal. Because even if I have 1 and 2, if I do 2, 1, 3 first, no, I definitely need to push first and then do it. So I push and then do this. That's fine. I push and then do this. Okay. I push. You see, no, in this case, we can't. I can't push and then do that because that's going to get everything out of order. So I need to move everything first and then push. So move, there's nothing to move, and then push. Okay, move, push, and then move. Okay, move, push, and then move. Yeah, I guess that's the way to do it. So move, push, move. That's how it is. Move, push, move. Move to non-empty. Push to non-empty. Move to empty. So maybe here we can say, is there like a nicer way for me to do this? Push to non-empty. Nice. Best Nest PT is now following. Thank you so much for the follow. Really appreciate it. Glad to have you around. Okay, so move to non-empty. So we have maybe I should also call this like non-empty. So this stack one dot length. I'm curious if I do. Well, I guess null coalescing is just that, right? If I do this and this, oh, that would be awesome if that worked just like that. Or if I do, the thing is, I think they're both, yeah, they're like, this is a truthy value. So even if I do, let's see. So will this one always pick, this one will always pick the full one. If I have, that's interesting. Oh, because that always picks. Okay, that's fine. Yeah, let's not make this complicated. Okay, so let's say non-empty. If this.stack.length is 0 is stack 2, and then empty. This.stack.length 1 equals 0. Okay, so let's do that. So we're gonna move to non-empty. So while non-empty dot length greater than 0, we'll do non-empty. We'll do empty dot push non-empty dot pop. That's the move piece. And then we'll push to non-empty. Wait, move to non-empty? That doesn't make any sense. So we have 1. Well, nothing here happens. Okay. We should push to an empty one. Before we do this, I move it to an empty one and then push to non-empty. Yeah, this should be move to empty. Yeah, while non-empty dot length, empty dot push, non-empty dot pop. Okay. And then push to non-empty. That's after the move. That's after the moving, and then we can say non-empty dot push x, and then while, let's see, non-empty dot length is greater than 0. Do we just do the same thing again? All right, let's go over this algorithm. Okay. Non-empty, if this dot stack dot 1, so I'm going to denote this by saying 1 and 2. Okay, if stack 1 dot length is 0, which it is, then non-empty will equal stack 2. Okay, so this will be non-empty, and empty will be this one. While non-empty dot length is greater than 0, so we don't do anything here, non-empty dot push x, which is here. And then while non-empty dot length is greater than 0, empty dot push, okay, dot pop. Okay, cool. Now we get to the next one. Non-empty. If this dot stack dot 1 dot length is 0, this dot stack 2. This is, oh, this is wild. This is not right. If this dot stack 1 dot length equals 0, non-empty. Yeah, okay, non-empty is, wow, why am I getting so confused with this? I feel like these are just terrible names here. Like empty, if this dot stack 1 dot length is 0, it should be 0 or stack 2, but see here empty will be, all right. If stack 1 dot length is greater than 1, if stack 1 dot length is greater than 1, then this is stack dot 1, else stack dot 2. Okay, non-empty is 1 and empty is 2. So from non-empty, we push to empty. Non-empty is stack dot 1. Yeah, but see, now this whole thing is in reverse. Why is that so tricky? Because I know we have the algorithm, but it's almost like this thing is switching every single time. But I guess all these operations are like, I have one where I think I have to generalize this a bit better. I have like one place where there's like one place where I have data. I need to move it to the other place and then move it back to that place. In the beginning, we have nothing. We just push it. Okay. Let me put the AC on in my house. Just 1 second. I live in South Florida, so it gets hot here. We need to make sure that AC is kicking. Okay, so we push here. I always need to move to the other one, push to that one, and then move back to the original one. Here, I move to the empty one. I push to the empty one. And now I move back to the other one. Here we move to the empty, push to the empty, move to the non-empty. It's just that one piece that we need to figure out. Maybe stack 1 and stack 2 are not. It's gotta be better than this. I know I just deleted a ton of code. I did that on purpose. So we want to push to the non-empty, I guess, whichever one. Push to non-empty. We move to the empty. So we just move to the opposite one. But like, what's like the nicest way for me to get the opposite one? Because that's gonna be, those will be changing every single time. What we always have is the goal to keep 1 on top in the end, so it's first out. Keep 1 on top in the end. So yes, exactly. Yeah. So this is, by the way, this question is implement queue using stacks. Yeah, we just have to continue moving them between both. So that way the first thing is always on top. So it's the thing that we can pop. And I think we're always going to like move to non-empty, push to the one we just moved to, and then go to the other one. So I guess let's think about that. Let me try that again. Non-empty is if this dot stack 1 dot length is greater than 0, then the non-empty is this dot stack 1, else it's going to be this dot stack 2. And then the empty one, yeah, I mean the same thing we had before. If anything, we're just sort of like repeating ourselves here. This dot stack 1, this dot stack 2. So we want to push to the empty one. Let's see, the next time we go, well, we should push to the non-empty one. We'll move from non-empty to empty. So while non-empty dot length is greater than 0, non-empty dot push, non-empty dot pop. Okay. Fine. Okay, so we get to the next one. Empty dot push, non-empty dot pop. Then we could say empty, because empty is still going to be empty dot push x. And then while empty dot length greater than 0, non-empty dot push empty dot pop. Actually, I think that's fine because the pointers will still be always alternating, right? There'll always be one thing that's empty. So let's say we have 1 here. So non-empty, if this dot stack dot 1 dot length is greater than 0, but it is 0, so non-empty is 2. Empty is 1. Okay, so from non-empty we push whatever is on pop, empty dot push 2, and then empty back to non-empty. We're gonna push 3, we'll do non-empty to the other one. Okay, so I think that's fine. Now from pop, let's see, const stack to pop is this dot stack 1 dot length equals 0, and it'll be this dot stack 2, else this dot stack 1, return stack to pop dot pop. I guess here we can do the same thing again, but this time we'll just return stack to pop dot length minus 1. myQ prototype dot empty, return this dot stack 1 dot length equals 0, and this dot stack 2 dot length equals 0. let me try this out. I feel like this definitely took me longer than I would have liked, but I think it's all right. We're good. Okay, so null, 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 1, 1, false. So, I mean, we got that piece, right? I wish there were more. I wish it was faster. Not fast, but I wish we had more cases. Okay, 54.96. I feel like I had the right answer many times, and I was just second guessing myself a lot. What is the follow-up, though? It says, can you implement that queue such that each operation is amortized O of 1 time complexity? In other words, performing n operations will take overall n time. Interesting. Yeah, this... Yeah, this is tricky because we probably need some other data structure to help us out with this that will make it so it's O of 1 time. I wonder if we can use like O of 1 time. Will using like an ordered set help us? No, an ordered set is going to do it in log of n time. And then unordered set, because I mean we can have duplicate numbers, right? Yeah. Not entirely sure. But I'm happy with what we came up with here. So I think that's pretty neat. 54.96. Let's get to the next one. Fair candy swap. All right, so Alice and Bob have a different total number of candies. You're given two integer arrays, Alice sizes and Bob sizes, where Alice sizes I is the number of candies of the ith box of candy that Alice has, and Bob sizes J is the number of candies of the jth box of candy that Bob has. Since they are friends, they would like to exchange one candy box each so that after the exchange, they both have the same total amount of candy. Okay, so 1 and 1, 2 and 2, 1 and 2, 2 and 3. Return an integer array where answer 0 is the number of candies in the box that Alex must exchange, and answer 1 is the number of candies in the box that, okay. I like to exchange one candy box each so that after exchange they both have the same total amount of candy. Alice sizes 1 and 1, Bob sizes 2 and 2. I'll put 1 and 2. Okay. I think I might know. So this is saying number of candies of the ith box of candy that Alice has. So does that mean she has 1 1 and 1 2? He has 2 1s and 2 2s? Or 2 2s, which is 4, but 1, but that's 3. One box of candy. Alice sizes I is the number of candies of the ith box of candy. So she has 1 of candy type 0. He has 2. She has 1 of candy type 1, and he has 0. They must exchange 1 of type 0. And why 2 here? This is so complicated. Bob sizes 1 and 3, 1 and 2. Bob sizes 2 and 3, 1 and 2. I'm not even sure. Like, this is confusing. There's so much text here. They would like to exchange one candy box each so that after the exchange, they both have the same total amount of candy. It is the sum of the number of candies in each box that they have. This is 2 and this is 4. She has 2 and he has 4, so okay, A has 2, Bob has 4. So if how many, I guess if she, or if Bob, number of candies in the box that Alice must exchange. If there are multiple answers, number of candies in the box that Alice must exchange. She can exchange 1 candy, and you will exchange 2. Do they each have the same? This is, I am very confused here. So I'm gonna do what I'm just gonna skip this one because I'm so confused about what they're even asking me to do, and I'm not sure how they're getting 1 and 2 here. And I'd rather do more quantity here. So let's get to water bottles. Okay. There are num bottles, water bottles that are initially full of water. You can exchange empty water bottles from the market with 1 full water bottle. The operation of drinking a full water bottle turns it into an empty bottle. Given the 2 integers, num bottles and num exchange return the maximum number of water bottles that you can drink. Num exchange 3. We start with 9 and num exchange output 13. You can exchange 3 empty bottles to get 1 full bottle. So we have 9. From there, we can do 9 to get 3, and from there it's 1. Here it's 15 and 4, so it's 15 plus 3. I think, is the answer just going to be like 15 modulo 4 is 3, okay, and 3 modulo 4, that's also 3, so that already like breaks that up. Num exchange is 4. We have 3 bottles. Oh, and then I see. I think we can do 15 modulo 4 is 3. And why are we left with 3 bottles at the end? Drink all of them. Oh, I see. We drink 15. Okay. And then for every 4, I get a new one. So I can get 3 more. So I drink all 3. And how is it that we get drink exchange? How is it that we get this? You can exchange 4 empty bottles to get 1 full bottle of water. 4 empty bottles to get 1. Number of water bottles you can drink is 15 plus 3 plus 1 equals 19. We have initial. You can exchange 3 empty bottles to get 1 full water bottle. And then we drink all 3. Okay, so we have 9. We drink all 9. From those, I can create 3 water bottles, okay? So now I drink all 3. From those, I can create 1, and now I have 1. So I have 15 water bottles. I drink all 15. From those, it takes 4 for me to create 3 new water bottles, right? I have 15 empty water bottles. So I can create like 3 new water bottles. Okay, I drink all 3. But I need 4, so where does that 4 one come? You can exchange 4 empty water bottles to get 1 full water bottle. Is it because we do the 3 and we have 3 left at the end? Oh, I think what's happening here is like, okay, we have 15 water bottles. We drink all 15. 15 full, and then we have 15 empty. We can create through 3 new bottles of full, but that still leaves us with 3 empty. So from the 6, how many can we create? We can create 1 from the 6, and that'll give us, yeah, I think that's how it works. So I think we always have to take off. We always have to take off from, yeah, let me see if I can come up with the formula here. So let initial equals num bottles. Now it's going to be some while loop here, but we can drink all 15. Let's see, let initial equals num bottles. I think I would like to change initial every single time. And I guess while initial is greater, maybe like while initial is greater than or equal to num exchange, const new bottles equals initial modulo num exchange. And then initial equals, let's see, or we can do initial minus equals new bottles. So let's think about this. Initial equals, let's do this. Initial equals 15. Is 15 greater than or equal to 4? Yes, it is. So new bottles is 15 modulo 4. So that's 3. Initial now minus equals num bottles. Maybe we can have, let's see, I can say let bottles left equals num bottles. While bottles left is greater than or equal to num exchange, bottles left minus equal new bottles. Or maybe we just want the difference, right? Let's see. So we have 15 modulo 4, which is 3. We can do initial bottles, initial plus or equals new bottles. So let's say this will be 18. Now, we have the 3 that we just created, the 3 new ones that we're able to drink, but then we still have some amount left over. Bottles left is actually going to be equal to, what's like, why am I like missing? I feel like I'm missing such a fairly simple thing here. We drink all of them, we create new ones, but we have 3 left. So we have a total of 6. From the 6, we can create 1 more new one, and that's it. Exactly. That's exactly what it's showing here. So 15 modulo 3, but we still have some empty bottles left. So we're always, initial is always going down. Yeah, initial is always going down from there. So I think maybe while bottles left is greater than or equal to num exchange, while we actually have bottles that we can exchange, we can create our new bottles. We'll add that to initial. But then what's the amount that we're left with? Maybe here I need to say bottles now is equal to whatever we started with, initial, (15 modulo 4 is 3. 15 minus 3, that's... It's another one of these confusing days. It's another one of these confusing days. that I just can't. You know what we should do that we didn't like? It's same thing happened yesterday, right? We didn't plan, and this is why this is happening. Let's really go through this. The part that I'm trying to figure out is here. How do we go from 15 to 6 and then to 3? Okay, because it's weird because in this case, oh yeah, we have 3. We can make 1 and we have 2 left. Yeah, so it's always like, how many can we make? And then the remainder, that's where I think it is, right? We can do 15 modulo, or 15 divided by 4. We can floor that. That's how many we can make, and then how many we have left. So I think here we can say bottles starts off with num bottles. Right, this is like our sum right here. And then we can say let initial also equals to num bottles. Here, while initial is greater than or equal to the num exchange, we want to say, okay, how many can we make? Right? That's going to be initial, so math.floor of initial, or 15 divided by 4 is 3. Okay, so let's say here we want to say bottles plus or equals math.floor of initial divided by num exchange. And then the initial now becomes, okay, how many do we have left? Right, after doing this whole 3, how many do we have left? We have 15 modulo 4, which is 3. So here it should be initial modulo num exchange. That's not, but we're not actually taking into account, it should be bottles. Let's see, we can say something like const bottles created. Maybe bottles created is math.floor. Maybe it's this, and then bottles plus or equals bottles created, and then initial equals initial modulo num exchange plus bottles created. Maybe something like this. So let's go through this, right? Let's say we have, these are both num bottles, so bottles is 15, initial is this. While 15 is greater than or equal to 4, bottles created is 15 divided by num exchange, which is 3. So bottles created is 3. Bottles plus or equals 3, which is 18. And initial is initial modulo num exchange, so 15 modulo 4, which is 3, plus the amount that we were created, which is 3. So now initial is 6. While 6 is greater than or equal to num exchange, here we can say math.floor of 6 divided by 4. We can create 1. Bottles plus 1 is that. And then initial is initial modulo exchange. So 6 modulo 4 is 2. 2 plus the 1, that's 3. 3 is no longer greater than or equal to num exchange. Okay. So now let's get to the next piece. Num bottles is 9 and num exchange is 3. So while initial is greater than or equal to num exchange, which it is, bottles created is initial by num exchange. So here we just add 12. And then we can do initial, which was 9, modulo 3, that's 0, plus 3. Okay, so initial is just 3, while initial is greater than num exchange, bottles created, oh, but then here 9 plus 3 plus 1, so maybe here initial bottles created, because it's like how many can we make plus however many we have left. So we have 9, we're able to make, maybe it's just however many bottles we created. But bottles created doesn't necessarily mean, because we can still have some left over. You know what too though? You know what we can also do? How many times does 4 go? 4, 8, 12. And then we have, yeah, but then we made 3. And we have 3 left over. Initial num exchange plus bottles created. 9 divided by 3, that's how many we created. And even if I just do a modulo here, that's not actually going to give me what I want. I'm missing a very simple number right here. There's just like one little piece that I'm missing. Why is this so complicated? From 15 to 6. I mean, that's 9. How do we even... From 15 to 6, that's 9. Is there any correlation there? Maybe it doesn't, because I feel like it doesn't really matter. We made 4, 4, 4, and we have 3 left. And that's the total that we have, is however many we made, plus we made 3 plus 0. Okay, we made 1. Yeah, so it should be the same. It should be the same thing here. Maybe, let me see. Bottles created is 9 divided by 3. We made 3. Okay, so we added 3. Now it should be however many there are left. Okay, however many there are left, that's fine. Okay, yeah, that's fine. Initial equals... Yeah, why did I think this should have been 3. Now initial equals initial num exchange. So 9 modulo 3 is 0 plus the amount that we created, which is 3. 3 greater than bottles created is initial divided by num exchange. So here 3 divided by 3, that's just 1. Right, we had already done this. And we're going to add that one. Okay. So now initial 3 modulo 3 plus bottles created is just 1. Now we're left with 1, so we just return bottles. Wait, did I just seriously like second guess myself nasty? Did I just really terribly second guess myself? Can we run this? Let me see. If this is the case, it's funny because this is the second time it would have happened, right? The same thing happened with the stack when I second guessed myself twice. 13, 19, 13, 19. Wow. Okay. This is and this is like a clear reason why I do these streams, right? Like literally for both questions, for Q with 2 stacks and this one, the water bottles, I was staring at the code for so long, doing something wrong, or in my head making it out to be wrong, but then I just click submit and it's right. So that's pretty crazy. Is there, and there's probably an even nicer way of doing this. I feel like I have one too many variables, because bottles and initial are the same, but we're gonna need to return the amount of bottles. Maybe I can just modify initial. I could just modify num bottles. Like anywhere I see initial, I can do this, and then bottles created. I mean, if I really want, I could do that. Get rid of bottles created. Will that still work? It's just like one less thing we can use. The only thing I don't like is we're modifying num bottles, right? 15.97. .04. Wow, okay. There must really be a way faster way of doing this. There probably is. Now I'm feeling really 28 point. Let me see the discussion. O log n and O of 1. Okay. Plus remainder, O log of num bottles, space O of 1. Okay, so yeah, it is pretty much what we did. So that's good. Okay, nice. All right, so I guess we ended up today with like two different parts, right? I guess we did a part 1, right? We did a part 1, which is this not, oh, okay, I don't know. This was some other weird thing. We did a part 1 and now we're doing part 2, which, you know, it is what it is. That's just how it goes. So we'll have to watch both of these to get the full stream, but we went a little longer today, so I feel pretty good about that. Pretty happy with the questions we did. So with that being said, I hope you all enjoyed today's stream. I'll be back here tomorrow to do a weekly roundup, and I hope you guys enjoy the rest of your Friday night. Take it easy, relax, go play some games. I'm probably going to keep playing some Cyberpunk. So I had a lot of fun chatting with you all today. Hopefully you all gained something from this, and I hope to see you all tomorrow. I'll probably be waking up a little earlier and doing something, you know, before 12 p.m. Eastern time. So with that being said, thank you all. Have a great rest of your weekend, and we'll be chatting again tomorrow. Happy coding.